Alright guys, so I'm going to be going over the tangent and cotangent transformations. As a reminder, this is what the parent functions look like. So remember tangent, the parent function is going to go from negative pi over 2 to positive pi over 2, and it's increasing, goes to the origin. For cotangent, you have asymptotes on the y-axis to pi, and then the 0 is at pi over 2, and it's decreasing. Alright, so we're going to we are on page 8, we are going to do the tangent and cotangent transformations. I'm actually changing 2 of the problems. So on the first problem, I need you to make this 2 tangent x plus 2. So change that first one to y equals 2 tangent x plus 2. And on this second problem, we're actually going to get rid of this whole thing. I don't want it. And I am going to make it y equals negative cotangent of 1/2 x. Let's make it plus 1. Okay. So, if at any point I'm going too fast, please feel free to pause this video to write down more. So as a reminder, the number up front is your A value. That's the vertical stretch or compress. And anytime you have a plus or minus with no parentheses, that is your D value, up and down. So this is going to vertically stretch, and you're going to multiply your y's times 2. And this is going to go up 2, which is actually 4 squares, based on how we let me zoom in, based on how we scale the graphs. This tangent, remember tangent goes into the negative, so when I'm doing this, I'm going to label negative pi over 2 to positive pi over 2. And I'm just going to quickly graph the parent function. 1, 2, 3, negative 1, negative 2, negative 3. I'm going to lightly graph it, actually. Tangent, remember you need to label the pi over 4s. And negative pi over 4. And that is the parent function. And now I am going to do my transformation. So I'm going to multiply the y values by 2, and then I'm going to go up 4 squares. So negative 1 times 2 is negative 2. And then I'm going to go up 1, 2, 3, 4. 0 times 2 is just 0. And then I'm going to go up 1, 2, 3, 4. 1 times 2 is 2, and then I'm going to go up 1, 2, 3, 4. Don't forget to draw your asymptotes. And we have a point right here, so we have to make sure that we're labeling that 4 right there, or else that would be a point off, because that point's right there. We labeled our pi over 4, negative pi over 4, so we're good. This did not have a B value, so remember my period for tangent functions is pi. And for all of these, tangent will always have a range of all real numbers. Again, we multiplied the y's by 2 and then went up 4 squares. And that's that. For my second example, we have y equals tangent of 1/2 x. So this 1/2 is between tangent and x, so this is my B value. Remember, tangent is special because before when we did a B value to find the new period, we always did 2 pi divided by b. Well, because it's tangent, we are just going to do pi divided by b. So pi divided by 1/2 keep, change, flip is 2 pi. Now tangent is special because it goes in the negatives. The horizontal stretches are also different. Whenever we had a horizontal stretch, let me see if I can go back to that page, for sine or cosine, don't you agree we just like squished it? We kept our y-intercept and we squished it. Or we kept our y-intercept and we expanded. That's not going to happen with tangent. Tangent is going to stretch horizontally from the y-axis, meaning in the middle or from the origin. It's going to go out both ways, in both directions. Where sine, cosine, actually all of them, cotangent, secant, cosecant, are all going to stretch to the right out. Tangent's going to stretch both directions. So in this case, since my new period is 2 pi, I'm not going to go all the way to 2 pi. I'm going to go 1, 2, 3. Negative pi over 2 is where I normally go. But now this time I'm going to go to negative pi all the way to positive pi. Do you agree that is a distance of 2 pi if I'm at negative pi and I go to positive pi? So this stretches both directions. So stretch horizontally from y-axis both directions. Everything else just stretches to the right, but not tangent. Now this is the only transformation. We have nothing else, so I'm going to go through 0, 0. And then remember, tangent, normally the parent function goes up to 1 at pi over 4. So my parent function normally at pi over 4 goes up to 1 because it's in between pi over 2 and 0. So this time it's going to go up to 1 at pi over 2. And it'll go down to negative 1 at negative pi over 2. And of course the range is all real numbers. And there you go. Okay. For my next one, I changed the equation again. Please write this new equation down. And so for this one, I have an a value. It's really a negative 1 right there. So that's going to reflect across the x-axis. I have a b value. We're going to have to get that new period. And I have a d value, which is going to make me go up 1. But be careful, up 1 is 2 squares. So let's figure out what our new period is. Remember, when we do new period, cotangent as well is going to be pi over b. So pi over 1/2. We just did this, so we know it's 2 pi. Now again, tangent is in the middle. Expands out, stretches out both directions. Cotangent does not. So here is my cotangent parent function. I have an asymptote on the y-axis. That asymptote is going to stay on the y-axis, and it's going to stretch to the right to 2 pi. Not going both directions like tangent. So I'm going to have 1, 2, 3 pi over 2. I'm still going to have my asymptote on the y-axis. When you're drawing, please make sure it's obvious you have an asymptote drawn there. And this doesn't shift left or right, so I can do this asymptote at at 2 pi. Now 0 would be at pi. And remember, cotangent goes down. So this would be at -1, and pi over 2 would be at 1. This would be what the graph looks like if all I had was a b change. But I also have to reflect over the x-axis and go up 2 squares. So now I'm going to take these 3 points, reflect them over the x-axis, and then go up 2 squares. Reflect this over the x-axis, that doesn't move, go up 2 squares. Reflect this over the x-axis, so it's at -1, go to 1, and then go up 2 squares. And my range is all real numbers. So that actually now looks like a tangent function because we reflected. Tomorrow during class, if you have any questions, we'll have a little bit of time to go over this, and you can ask any questions to your teacher about what you have. All right, last one. Last one has no A, no B. It's super nice because all I'm going to do is shift right pi over 2. And remember, that's 3 squares. There's no B value, so my period is just pi, and I'm going to go ahead and fill out the range because we know it's cotangent. It's going to be all real numbers. 1, 2, 3, pi over 2, 1, 2, 3, pi. I'm going to really quickly, lightly graph the parent function. That's just my parent function. And then I need to go right 3 squares. So I'm going to take each point, 1, 2, 3, 1, 2, 3, 1, 2, 3, and go right with each point. And I even got to take each asymptote and go right 3, 1, 2, 3. Don't forget your arrows on all of these. Every single tangent and cotangent needs arrows. And then don't forget to label this right here, 3 pi over 2, because you'll get points off for that. And that's it. All right, tomorrow in class we'll go over this more. Just as a reminder, big thing I need you to know is cotangent stretches when it's stretching horizontally to the right, goes out to the right. Tangent goes both directions. All right, thanks for watching.